Hello there, everyone. This is the second lesson in Unit 9, which is on the volume of solids. And in this lesson, we're going to take a look at calculating the volume of cylinders and also continuing our learning about volume of prisms with our triangular prism. And that's where we're going to start here. So remember, volume is a word that we use to describe the capacity of a container. So how much a container will hold or how much space an object occupies within 3 dimensions. And for any prism, so we talked about rectangular prisms and trapezoidal prisms in the previous lesson. For any prism, the volume is calculated by taking the area of the prism's base and multiplying that times the prism's height. So you have to be able to make sure that you can correctly identify the base, because that's the one you have to calculate the area of. And what we have learned is that the base of a prism is the shapes that are not rectangles, if there are shapes that are not rectangles. And if everything, all sides are rectangles, then the bases can be any 2 opposite rectangles. So for a trapezoidal prism, that meant the bases had to be the trapezoids. So we had to calculate the area of the trapezoids. For a triangular prism, that means that the triangles will be the bases. And that's what we'll have to calculate the area of. So we will need to, of course, use the area formula for a triangle, which you may or may not remember at this point. So here is our area of a triangle. We take 1/2 times the base edge of the triangle times the height of the triangle, not the height of the prism. That's the difference here. We actually have 2 heights and we need to know which one's which. The height of the prism, remember, is the length that is perpendicular to the base side. So if we're looking at the triangles being the bases, the height of the prism would be perpendicular to that, or a side or an edge rather of a rectangular side. So here's our triangular base shown here in the front, and also the other ones in the back. Here's the base edge. Here's the height of the triangle. And so these are the measurements that we would use. And notice the height of the triangle is perpendicular, meaning it forms that right angle with the base edge, that little b. So we take the height of the triangle and the base edge, which are perpendicular to each other. We multiply those. We divide by 2 or multiply by 1/2. You can also do this calculation if you prefer, because multiplying by 1/2 and dividing by 2 are the same mathematically. And then we take that area times the height of the prism, and this is also a right angle. So this is the height of the prism, which goes from, remember, from base to base. So the height of a prism is the measurement that goes from base to base, assuming it's not oblique, which we're going to look at later. Oblique means it leans, and we haven't looked at that yet, I don't think. So here we are looking at now applying this to some problems. Here's our first problem. So we are to find the volume of the tent in cubic yards. Now, our picture doesn't look much like a tent, but that is our context. This is a triangular prism that is modeling a tent. And I think we've probably all seen tents that do look like this. We want it to be in cubic yards. Make sure you're paying attention to your units and checking. So notice that all of our measurements in our picture are already in yards. So we don't have to do any conversions for this problem. But what I do have to do is recognize I have a triangular prism. Know that for any prism, prisms, remember, have rectangular sides, that the volume is the area of the base shape times the height of the prism, and that my base shape is a triangle. So I have to use the area of a triangle. And I'm just going to use that division one here. But you can use the times 1/2 if you prefer. So now I have to figure out which of my numbers is which. So here I'm looking at recognizing, okay, here's a right angle in my triangle. And what's perpendicular is this measurement, which is 18 yards, and this measurement, which is 7 yards. So that makes the side of the triangle 7 yards, the base little b, and the 18 the height of the triangle. The height of the prism goes from triangle to triangle, from base to base. So the 12 yards is the height of our prism. So now I'm going to plug in those numbers. So my little b is my 7 yards times the height of my triangle, which is 18 yards, and that's divided by 2. And then I'm going to take that times the height of my prism, which is that 12 yards. Now, I like to always put my units into my math to make sure that I'm going to get the units that I'm supposed to get, which is cubic yards. And here I see with my units, I'm going to take yards times yards times yards, which is going to be yards to the third power, which we call cubic yards. So that all looks good. Now I could use a calculator here, or for some of it, I'm going to share with you some basic math tips and tricks to speed things up and be able to do things more easily without a calculator. But you can use a calculator here if necessary. So notice that this is 7 times 18. That makes 18 a factor. And so we can actually divide or reduce the 18 and the 2 that's in the denominator. And that would give us then just 7 times 9. And 7 times 9 is 63. So what I now have is 63, and yards times yards would be square yards times the 12 yards. And then, of course, I can use a calculator here if I want to, or I can multiply that out. So here are 63 times 12, 756. And yard squared times yard would be my yards to the third power, so technically I'm adding exponents of 2 and 1, and that's what we call cubic yards. So then we want to write our conclusion. Remember, it's the context, so this is representing the volume of a tent in context. So the volume of the tent is, we don't want to use about here because we never had to approximate around anything. So is 756 cubic yards. Now you can go ahead and use the exponent notation for cubic yards that's shown over here. That's fine. Or you can write it out in words. You should be able to do both and understand what each of them means, that they mean the same thing. All right, here is a practice problem. I encourage you to pause the video here and try this practice problem. All right, we're going to take a look at the answer now. So hopefully you came up with 30 cubic feet. So if not, let's talk about some of the places where you may have gone a little wrong. So with this particular problem, our units are supposed to be cubic feet. We have 2 measurements that are in feet, but 1 that is in yards. So the first thing is we want to convert that yards into feet. So we need our conversion ratio, that there are 3 feet in 1 yard. And so now our yards cancel, and that leaves us with 6 feet. So now we know this is equivalent to 6 feet. Then we need to make sure that we understand our volume formula and what numbers go where. So here, this is perpendicular to this in our triangle. That makes the 5 feet, the little b, the base of the triangle, the 2 feet, the height of the triangle. The 2 yards, which we converted to 6 feet, goes from triangle to triangle. That makes that 6 feet the height of the triangle. Sorry, height of the prism is what I meant to say. We've already done height of the triangle. That makes, from going to triangle makes it the height of the prism. We want to make sure we use that 6 feet not accidentally the 2 yards. So here it shows the 1/2 times the base of the triangle times the height of the triangle, and then times the height of the prism. And we have feet times feet times feet, which is our cubic feet. You can look at this as the 2's reducing to 1, leaving you with 1 times 5 times 6, which is that 30 cubic feet. And then the context here is this is representing a toy block. So the volume of the toy block is 30 cubic feet. All right. Now we're going to talk about cylinders. The nice thing is that in general, volume of a cylinder is calculated the same way as a volume of any prism. We take the volume, or we calculate the volume by figuring out the area of the base, which is the circle, and multiplying that times the height of the cylinder, which goes from circle to circle. So the circles are the bases, and height goes from circle to circle, from base to base, just like a prism, and we still multiply that area times that height. And here, though, we have to, of course, realize, all right, we have a circle for our base area, so we need the area formula for a circle, which is shown right here, pi r squared, where r is the radius of the circle, which, remember, radius goes from the center to the circle's edge or circumference. All right, so let's take a look at a problem. So here we are to estimate the volume of the barrel. We're to do so in cubic inches. Here our instructions are a little different, and you'll see this fairly often with problems involving circles. They want us to write our answer in terms of pi, which means we have our pi symbol in our answer, and then also to the nearest tenth, which means that we use our calculators and the pi symbol on our calculators to approximate as a decimal. So we have cubic inches as our goal. Notice it says estimate, and that's because most barrels are not perfect cylinders, but the cylinder is probably the easiest model that we can use to estimate the volume. It's pretty close to being a cylinder. So we are technically estimating. We're getting pretty close by pretending this is a perfect cylinder. So we want it in cubic inches. So we have one measurement in inches, but our other is in feet. So the first thing we're going to want to do is take that 2 feet and convert it into inches. So our conversion ratio, remember, we want to get rid of feet. So we have feet in the denominator, 1 foot, and there are 12 inches. That's what we want to end up with in our numerator. So now the feet would cancel. And we've got 2 times 12, and we know this is 24 inches. And you may have even already known that, which is good if you know that mental math. So now the 30 inch, we've got everything in inches. Now we're looking at our volume formula and figuring out what's what. So with our volume formula, remember, which is area of the circular base times the height, we know area of the base is pi r squared, and then times the height. So we need the radius of our circular base. So looking back here, we need to realize this symbolism right here is saying 30 inches measures from one edge of the bottom circle to the other. That, you might recall, is what we refer to as diameter, not radius. As we said earlier, or as I reminded you earlier, radius is from the center out. So what is the relationship between a diameter and a radius of a circle? So we need to realize that radius is half the diameter. So when we want radius, but we have diameter, which we call d, we have to divide it by 2. So we're going to take that 30 inches and divide it by 2, and that's going to give us a radius of 15 inches. We also need our height of our cylinder. And remember, height, like for a prism, goes from base to base. It goes from circle to circle. So that would be this measurement here, which is the one that we converted. So we've got to make sure we use that 24 inches, not accidentally that 2 feet. And that's one of the reasons why I like to, once I convert a number, I like to label that in my diagram and maybe even cross out the old one to make sure that I use the correct number later on. Don't make a mistake. So now my volume is going to be pi times my radius of 15 inches squared times my height of 24 inches. Now notice how I've written this, 15 inches inside parentheses, and that's really because when I square my radius, I am squaring the number of 15 and the units of inches. 15 squared, you might know, is 225. And that's going to give me then 225 inches squared, or square inches, times this 24 inches. Here I'd probably use a calculator to speed this up. So I'm going to take 225 times 24. And I get 5,400. So this is 5,400, and inches squared times inches would be inches cubed. Again, because I'm adding the exponents of 2 and 1 to get that 3. Now, here's where we got to be careful. Remember, we're supposed to write our answer in terms of pi. Remember, here's our pi over here. So these two things together now give us an answer of 5,400 pi cubic inches. This is the one that's in terms of pi, meaning that pi is in the answer. And this means multiplication, 5,400 pi, and this was that operation here. All right, so we're keeping everything consistent. Now to get our approximation to the nearest tenth, we're going to use our calculators and take that 5,400 times the pi key, not times 3.14, which is a rounded value for pi. We want the most accurate answer as possible. So find the pi key on your calculator and use it. So if we take this times pi and then round to the nearest tenth, we get a pretty big number, 16,964.6. So 16,964.6, and our units, of course, are still cubic inches. So now I am going to write my conclusion. So the volume of the barrel is estimated to be about 5,400 pi cubic inches. I think I'm going to use my power notation here, or about 16,964.6 cubic inches. So notice the structure of my grammar. So I included both answers. They're both technically approximations because remember, the barrel is not a perfect cylinder. So that's why I used about on the 5,400 pi, even though I didn't round there. I am estimating, and both of these are technically estimates. And then I connected them by or, since I'm looking at it either as in terms of pi or as a decimal. All right, so here's a practice problem. I recommend that you pause the video here, give this problem a try, and we'll look at the answer in a moment. All right, let's look at this answer. So for this one here, we are using our cylinder to model this log. All right, piece of a tree trunk, it looks like. We want our units to be in cubic feet. We have one measurement in feet, one in inches. So the first thing is to convert inches to feet. So we wanted to get rid of inches. This time the 12 inches is in the denominator. This leaves us with feet, and we get 3.75 feet. So now we're going to use our volume formula for our cylinder, which, just like for a prism, starts out with base area times height, but our base is a circle, so pi r squared for that area. Here, the 2 feet, notice, the measurement is starting from the center to the edge, so that is the radius. We don't have to use that diameter divided by 2 here. That would be incorrect. And the 3.75, which goes from one circular end of this log to the other, then would be the height of our cylinder. So we've got the 2 feet quantity squared. The 2 will be squared, the feet will be squared, giving us 4 feet squared. And then multiplying the 4 and the 3.75 together gives us 15. So pi is our 15 pi cubic feet. And then multiplying the 15 times the pi key and rounding, about 47.1 cubic feet. Here's a slightly different wording. The estimated volume of the log is 15 pi cubic feet. We know this is an estimate because of the word estimated earlier. And then it says which is about, and then gives a decimal answer. That's also a good way to write something like this. All right, here's another example. So here we're to find the volume of the can. And again, a can is not a perfect cylinder, generally speaking, but it's probably our best model to use for a quick way to find the volume. This time it gives us a base area. So be careful with this. Always be thinking about your terminology and what it represents in terms of the information that you use in the formula. So the base area is 25 pi square inches. And it says we have a height that's equal to 3 times the radius. We are again supposed to write in terms of pi and to the nearest tenth. But let's go back to this 25 pi square inches. Base area, remember, is your capital B. So if we want to find the volume, which is our base area times our height, we actually already know our base area is 25 pi. What we don't know is our height. And notice it tells us something about the height. It says our height is equal to 3 times the radius. But then we go looking for the radius and we see nothing mentioned here. No numbers at all in our picture over here for radius. Nothing else said about the radius. But we do know that the height is 3 times the radius. So the question now is, well, what's the radius? So we can figure out this height that we need for volume. So here's where it goes back to knowing how this base area for a cylinder is calculated, that this 25 pi came from the area of a circle formula. So to find that radius, which is our R, we have to know that our 25 pi is a calculation of pi times the radius squared. So this is actually now a simple little algebra equation. It's a little quadratic algebra equation that we can solve. Remember, 25 pi means 25 times pi. So we are going to undo that multiplication and divide both sides by pi. And notice they'll go away on both sides, leaving us with 25 equals r squared. Now we'll undo that exponent, taking the square root of both sides. Now, technically, our square root property requires a plus minus, but remember, we're in context here, and r represents technically that plus minus would be over here. R is a measurement. Measurements can't be negative. So we use here what we call the principal square root. The word principal means just positive. So here we just want the positive or principal square root, which is 5. And so now we know our radius is 5. And because the base area was in inches squared, and we took the square root of that, we know this is now in inches. So now what we're looking at is figuring out our height. So this is kind of the first math we do. Now with second math is we figure out that height, which is 3 times our 5 inches. So we know that our height now is 15 inches. And now we can use that volume calculation. We'll just keep that 25 pi, which remember is square inches, times our height, which we now know is 15 inches. And we're going to get inches times inches, which will be inches cubed. And remember, we do want in terms of pi and to the nearest tenth. So right now I'm just going to take 25 times 15 in my calculator. And it gives me 375, which is also times pi. So I get 375. That's not a 7. Pi inches cubed. Now I'm going to round it. So multiplying my 375 times my pi key and rounding to the nearest tenth, I get 1,178.1. Still, of course, inches cubed. So now we're going to write our conclusion. So here we were finding the volume of the can, and in both terms of pi and the tenths. So the volume of the can is 375 pi cubic inches, or which is about 1,178.1 cubic inches. Alrighty, done with that one. Here's a practice problem. Again, I recommend you pause the video here. We'll take a look at the answer to parts A and B in a moment. All right, let's take a look at our answers. So here for part A, where we're estimating the volume of rainwater the container will hold, that we're looking at finding the volume of this cylinder container. We want it to the nearest cubic foot. Both measurements are in feet, so no conversions are necessary. Now notice, you might have been wondering about what the 2.5 feet represents, but notice it's next to a line that goes from side to side on that circular bottom. So that means it is a diameter. So we have to divide it by 2. That's where this radius came from. If you had some trouble here, your height is from circle to circle. So that is your 3.25 feet. Then we plug it in. And here we just want it to the nearest cubic foot. Remember, foot is a unit here. When it says cubic foot, that means ones place or nearest whole number. So that's why we're at about 16 cubic feet. Part B says we're to estimate the rainwater that Mrs. Molina saved to the nearest gallon. And then it gives us a conversion that involves our cubic feet units. So we can take then our volume estimate of 16 cubic feet, multiply it by a conversion ratio so that we get rid of our cubic feet, they cancel out, and leave us with gallons in our numerator. And then that would be 16 divided by the 0.134, since the 0.134 is in our denominator, and it gives us about 119 gallons of rainwater. It's a pretty big container. All right, now for the closure for our lesson. So this is something you should be able to articulate in your own words. Explain how to find the volume of any prism or cylinder. So this is a general explanation, the general way that we can find the volume of any prism or any cylinder. All right, so hopefully you remembered that what you have learned is that prisms and cylinders, their volumes, are both calculated by taking the area of the base times the height of either the prism or the cylinder. That's our general way to find the volume of any prism or cylinder, is to multiply the area of the base and the height. All right, that finishes up this lesson. I hope you have a wonderful day.